Yeah, I think we are ready to start. Okay. Before starting our session 2, let me just make a quick notice about new platform. Do you see my screen?
Yes.
Yeah. As I sent it out on email a couple of days ago, we created our communication channel on web or on a mobile app. You can really easily access to a kind of dashboard here. So you can just post a question or any quick ideas or any troubles you have, and we're gonna respond here ASAP. So please use this effectively, hopefully. Okay, and did you guys have any troubles or any problems after session 1 or any after the prep session of yesterday? Everything good?
Yes.
And are we ready to move on now? Okay, so today we're gonna go deeper into Python and scripting, and it will be led by NJ mainly, right?
Yep.
Yeah. Through more exercises, but don't hesitate to interrupt with any questions or any troubles that you have. Okay, so shall we start?
Sure. So do you guys can see my screen?
Yes.
Great. Previously, Dr. Jung Young introduced history, education, or some theory of network analysis in the previous lectures. Today, I'm going to talk a little bit more about network analysis in terms of the technical depth, things like that. But before I talk about the network analysis using the Python, I actually, Sumin asked me to share my definition of computational design. So I prepared 3 small slides before we start. So the first slide is this one, yeah, data and design. So the reason I'm trying to share my definition of computational design is to basically help us to on the same page. So my definition of computational design is more about like creating a system, pipeline, or some flow of data in action based on people, So I'm not going to talk deeper because I already created 2 versions of the video in English and Korean version. So you guys can see if you are interested in. But however, I have a very quick slide here. So, I mean, I have a question for you guys. What do you think about what is the most expensive product in the world? Yeah, probably you guys have your own sort of answer in your mind. But I guess not the most expensive, but such as like Google search engine or Facebook or Instagram. This kind of product is really expensive, right? So, I mean, I'm working as a software engineer in the United States. So we designed a product that's a little bit different than architectural design. We basically build a product such as GIS, ArcGIS product or story map, things like that. So we have design system. So what I mean by that is design system is basically has a set of rules or set of inaction or even the pixel level. Yeah. So based on this kind of rule, we built some application. So design system is really important in terms of how the direction of the product, how we maintain. If we have some sort of let's say edge cases or corner case, if you face some edge cases, we need to set up the rule and we need to define the rule in order to make it correctly. So my definition of design system, again, for the architectural design, is more about creating rule or system, sort of like ecosystem, how data can be evolved or how the data can be tweaked based on our inaction. Yeah. So in this context, we have three distinctive topic here. One is the first one is data. The second one is the methodology. The last one is, let's say, system. So as you can see, the data, we have a lot of data, actually full of data. A lot of people talk about, first industry revolution, right? But I guess without understanding of data, it's almost impossible to understand what's going on behind the scene of first, revolution. Because the essence of the first industrial revolution is all about the data, actually. So, fortunately, we are designer. We have a lot of data in different levels, from the product geometry or urban scale or landscape, even the inaction. Yeah. The inaction also can create a lot of data, basically. So the second thing is about the methodology. My understanding of a methodology is more about how to deal with data. Yeah. So particularly, we are designers, we're dealing with some spatial information, right? Geometry is basically set of pointers in a space and then connectivity. That's it. Yeah. So there are three main, sort of methodology to deal with the data. Let's say spatial data. Yeah. The graph, that is important topic for our workshop. And the second thing is the pixel, like a matrix, 2D matrix. The third one is the voxel. Voxel is nothing special, just it has an extra Z dimension from the pixel level, let's say 3-dimensional matrix. Yeah. So when it comes to system for design, I think there are several keywords that you're already familiar with, such as automation or agent-based design or optimization or generative design. I think this is more about how we deal with the data and the data structure. This is basically direction. Yeah. So on top of the system, we have the resources data, and then we have a tool to manipulate the data in a space. And then we basically, even same data process or methodology, we apply different direction. Yeah. This is what I'm trying to say. And then the most important thing is that, I have the other question. What is definition of software for you guys? Some of you guys maybe think about like a Rhino's software or Photoshop or 3ds Max or Maya. Yeah, this is one of the software, but I think this is a very poor understanding of software. So my understanding of the software is a way to pack the knowledge in a usable form or a mobile or distributed structure. Software is not just tool. Software has a bundle of the knowledge and technique, method in action series. Yeah. I really like the term, like, standing on the shoulder of giant. Yeah. I think throughout the history, human being built a lot of science and math here, right? Usually, computation design, we basically dealing with something to compute, right? Like geometry or statistical insight. So software is basically contain a lot of history and insight and math equation that people already built it. So we take advantage of the existing insight or existing wisdom in order to resolve your design problem. I think this is essence of the software, I guess. So software is not only has the action of the sequence, action of the method or action of the functions, but also it has an interaction. I only play the StarCraft, which is like my favorite game. But the game has a lot of interaction between computer and human, right? But think about it, 3ds Max or Maya, it has thousands of command and combination of commands, right? So what I'm trying to say is that the CAD software, computer-aided design software, is a lot of interaction compared to the VR or AR or like in a game. I don't know. Recently, a lot of games happening, but I don't know how complex in terms of interface. Basically, interface is sort of a gateway between human, intuition and human interaction with the computer interaction. Yeah. So anyhow, so the software is really important. And then maybe after this time, we have. I would like to ask you guys, rethinking what is software and how we build design strategy or computational design methodology or design system as a software. The software is not just like one executable file. This is a set of knowledge, maybe based on your design or architectural design or urban design. Based on your project, we can produce the software actually, and then the softwares can enact each other. Then they can keep evolving. This is, I think, a better way of describing software in our context. So yeah, these are pretty much about it. And if you guys are interested, I try to share my opinion. I think this is just my opinion. Yeah. Maybe some of you guys disagree with me, but that's fine. So there are some examples, some like keyword. Yeah. So that's it. Do you guys have any question about it? Great. Let's jump. Okay, we have one question here. Oh yeah, sure, absolutely. Yeah, I can share this page. Yeah, I think this is our main medium page here. Yeah, all material is inside of this page. It's like a root page. Think about graph. This is a root graph. It has a lot of node and connectivity. Okay, great. Let's jump to next topic here. Computational design thinking for designers. Again, this is my opinion. Yeah, I mean, specialists has their own experience and has their own definition. So maybe different people has a different background, experience, and understanding. But here is my thought and experience that I would like to share with you guys because, Sumin asked me, share. Okay. I don't know, somebody highlighted, I don't know if I'm missing something, like style or grammar. Anyhow, so this is the reason I create this page. So, the keyword could help designers to think, like a computational design specialist. Sometimes computational design in design, computational thinking in design, ask you holistic approach to resolve a small design problem, while also you extremely very isolated problem to fix a comprehensive design. This is sort of a dilemma. Okay. Yeah, this is a sort of a dilemma. Yeah, because I guess you guys have a lot of experience to communicate with your client or your professor, right? So, for example, I would like to move the window position from here to there. Or is it possible to, enlarge this room a little bit toward east direction? Yeah, this is easy to say, right? But however, in order to change your design, we need to rethink everything from, all the way like from the foundation, right? So software is a similar things. So I have a lot of experience to work with other designers because one of my interests and hobby is to ask design problems in different domains. So, but they just ask me, NJ, is it possible to create this solution? And then, yeah, we can do that. And then we can build a solution. And then meantime, the designer kept asking me, like, I think it's very easy. Can you tweak it a little bit? But I felt like I need to start from scratch because it's easy to say, but sometimes it's an absolutely different approach. So the reason I'm creating this kind of keyword page is hopefully guide you to at least like understanding each other between computational design and designer who has no experience. So first of all, I really like the first keyword here. In order to get right question, we need to raise correct question, right? So the rising question is really important. At the same time, we need to imagine, and also you need to set up your own hypothesis. But you know what? Without understanding or without the experience in the computation design, is almost impossible to imagine, right? It's really impossible to create your own hypothesis, right? Because simply you never experienced in that field, right? However, we can revisit here anyhow. So in order to create the right question, we need to understand problem first. So problem is, I feel like the design is also a solvable problem. Yeah, I think maybe this is a creative problem, but you can decompose the design exercise. Then you guys realize that you can focus on really small problem as design getting evolved, okay? So anyhow, we need to understand the problem, what you really want to resolve by computational way. I think this is important. And then, this is a very common thing, but a lot of people missing. We need to declare input and output. Yeah. So, for example, like, because a lot of people talk about machine learning, right, in artificial intelligence. So, here's my experience. I have several friends who majoring in machine learning in computer vision, MIT CSAL, which the guys asked me to finish my thesis anyhow. So when I talk with them, I just trying to ask him, like, this is my high level achievement. I want to really implement this kind of, let's say, result. And he keep asking, okay, NJ, so what's your input? And what's your output? He keep asking me, even if I'm a computation designer, it was sometimes really hard to communicate. This is just one example. So, for example, if you have your own client, or sometimes yourself become your client, right? Because I'm designing at the same time, and then also I need to resolve some computational problem, right? So in this case, we need to really clearly specify what is the input and output, just such as I have been working with the developing the NNA tool with NJ&Woo. She has no strong computer science background anyhow. So she asked me, like, she gave me a lot of idea. And then I just trying to distill what he said. And then I just summarize, okay, so I believe in order to achieve your sort of application, we need simply at least this kind of required parameter, required input. So I just trying to, like, let's say, arrange our long discussion related to the network system. So what I mean by that is that the declared input and output is really important. Once we have this one, and then we simply need to start coding. As you can see here, some if statement, if it's yes, go here, otherwise go there. It's like all about the flow. Yeah, it's logical flow on the very high level. On the low level, you need to type in like if declare variable, and then create a for loop or if statement and things like that. But I'm not going to talk about this for a little bit because I just want to talk about this topic on the high level first. So this is all about how we start, how we creating the computation solution to our design problem. And then this is a sort of a let's say mentality, yeah, when you approach your design problem. So sometimes we need to think very holistic strategy in order to resolve very isolated problem. This is very, I mean, it's weird, but it's true actually in computer science. And also, you need to really focus on one very strategically pinpointed solution that resolves the entire problem. This is all about like let's say architecture. When I say architecture, it's more about like how we design the algorithm, like a if statement and loop, things like that. And also, we sometimes starting from simple and to complex. I think this is the best approach, I guess. But sometimes we must start complex. So for example, like if you are familiar with the OOP, object-oriented programming, that one is you need to understand the entire like ecosystem first, and then declare some abstraction, yeah, and then you can create a concrete class out of the abstraction. In this case, we need to understand the entire, like a, let's say, a holistic big picture before start. And also, this is very important things, specific to generic. I think I would like to that part, basically. Because, so for example, as I said, we, Dr. Jung-Yeon and me, and we developed this plugin, right? So we starting from really specific problem, yeah. So we wanna resolve, we wanna get the shortest path in this particular system, right? So we have a very specific things. Actually, the building function for specific problem is easier, or way easier. But the generic, you know, function is really hard. Do you know why? Because it has a lot of edge cases or corner cases, yeah. Because we need to build one thing, and then that need to interact all other possibilities. So starting from the generic, yeah, sometimes we need to start because the environment. But you know, most of the computation designer can think from specific to generic stuff. This is a sort of a mental structure. So while you're developing your own algorithm, we need to keep thinking, keep repeating that keyword, yeah, in order to see where you are, right? And then the sort of manifesto or policy. What I'm trying to say in this section is direction, basically. There should be one direction, right? There's no two direction, right? Only one direction for one solution. So this is I think really important. Deterministic or sarcastic stuff. So deterministic way, deterministic computation is, let's say, in an easy word, every time you execute, the function guarantee exactly the same result. Yeah, there's no randomness involved in that process. Yeah, this is I think easy sort of concept. Okay. However, we have a sarcastic approach. So the generative algorithm and machine learning also can be considered as a sarcastic. If you are relying on the statistical methodology to develop your own result, again, we are on the way of with the sarcastic direction. Yeah. So this is different. I will describe why it's different. So for example, in a design problem, there's one of the famous, let's say, computation thing is to create a design space. Actually, he's one of my alumni in Berkeley. So he developed a dream capture in Autodesk. So what it does is just think about, you know, we build a antenna first, right? So based on the configuration of an antenna, yeah, I don't know my accent is right one, correct or not, but antenna, yeah. So they can receive the wave one now. So they generate the thousands of options, and then also the configuration of the antenna. Then they also need different types of material, right? So you can dump all the problem or issue, and then you can get like a, let's say, in this context, it's not the best, but optimal result, right? So this is the like a problem of the convergeable diverge. I'm always asking my friend, like, if you have, such as I engaged in one more project, which is to build a parking lot in Singapore. So in this context, I asked my client, what do you want? Like, do you want to see all the options, or do you want to see only the best result out of your site? If you really want to get the best result, that we can take the converge way, yeah. We can focusing on, yeah, to maximize your result. However, if you wanted to see a lot of options, within the exact same situation, we can also take it the diverge way, because we wanted to explore the space in a sarcastic way, right? So optimization is one of the example, right? Because there's a lot of way to optimize one structure, for example, and also there's only one best way to optimize this particular structure based on the material, whatever. And also we have a very good example, parenthesis, I couldn't remember all. Efficiency, but there's the other way of term. Yeah, like a graph. Yeah, parenthesis graph here. So this graph talks about the efficiency. So what is the best combination within your parameter that you inject to computation process. Yeah. So for example, if I have if I'm able to expose to enough sun to that, like a courtyard, for example, but at the same time, you couldn't get enough ventilation, for example. So you need to give up one thing and then get more, and then once you give up something, and then you can get more other opposite things. This is like a seesaw, So you need to pick one of a combination. So this parenthesis efficiencies give us like a combination of the parameter in a sarcastic way or deterministic way. I think this is just a good example in this way of describing sort of policy things. And also, I think that this is you guys are already very familiar with. Architecture designer also talks about a lot like top-down approach and bottom-up approach, like holistic approach or partial approach. This is a very, I don't need to explain, right? But that one is also very interesting, right? So there's two things. One is we need to find existing solution, yeah, correct. But at the same time, we have no idea about the exact solution. So we need to rebuilding the solution. I think this is a little bit different sort of explanation of deterministic versus sarcastic things. So for example, like optimization is possibly, we can apply like an existing solution. We need to find an existing solution, right? And then as a visualization specialist, in my experience, more about like the visualizing urban data on the map is more about rebuilding insight. Yeah. So in this case, we have no idea what is existing things. Basically, we can visualize existing context. And the existing context is basically revealing something that we never found before. This is also important sort of mental stance. Yeah. And we have also the concept oriented and disoriented, which has something to do with the object-oriented program things. Okay. Okay. We have, give me 10 more minutes. I can finish this slide. Yeah, and then this is also a little bit important things. So procedural way is it has a distinctive steps. So once you forward one more step, you don't need to come back to the other step, the previous step. But however, the iterative process, it's like we need to go there and then make some loop. We keep iterating the process until meet some condition, and then we go the other direction. So this is the also important concept for the computation design, like procedural and interactive, iterative process. And this is the same as before. Sometimes we need to find the best, the best result. But sometimes we need to focus on the optimal result because we have no idea what is best result. Okay. And then implementation. The implementation is we keep narrow down. Okay. So from the very high level stance toward how you implement the code here. So basically, it always happens from to, right? So the real world is actually infinite data and information. So we need to finite them. This is absolutely important. Otherwise, there's no way to compute infinite information by computational way. Do you know why? Because simply the computer has limited memory. Yeah. So finite is a really important concept. Also, sometimes we can call it like discretization, things like that for the let's say fabrication domain. But I can give you some like image here. Finite element method. This is a very old and important method, particularly compute something in a discrete way. Yeah? So for example, like a structure analysis. So actually this is a graph. One has a node and then edge. So to create the graph is more about your ability to abstract something into into something that we can compute. Yeah. So basically we have like a node edge, and then the edge can be divided multiple small finite elements. We call sometimes it a mesh. So individual mesh can be become as a sort of a place where they calculate the strength, like a tension, compression, you know, structural engineer. Yeah. Okay. Let me jump quickly. And then obviously people, even if you are very, you know, you can consider yourself very expressive person, but however, you are not that expressive person compared to the computer. So computer always we need to mention explicitly. Yeah, this is important thing. Obviously, we talk about ambiguous things. We need to make a very clear instruction to computer to compute. And then sometimes your thought process is very entangled, just like a spaghetti, yeah? But we need to clearly separate. This is more about like a pipeline. How we design some group, and how we reach, for example, this is a little bit different diagram, but just ignore it, the server side or whatever. But let's say this is controller, for example. The controller wanted to tweak some geometry. So they actually can control the geometry directly, but this is not a good way to create your own, you know, design pipeline. We need to make some controller. So throughout the controller, we need to tweak your geometry. I mean, this is sort of like a very high level description. I will revisit this one again later. So this is more about like how we code, how we observe phenomena, and then how we can create a code, some modeling, which is sometimes considered as a system, which is because we created the mathematics system and modeling. This is predictable. This is like even if you can use the randomness or whatever, it should be deterministic things. So let me scroll down quickly. So this is summarized. Yeah, quick summarize. The first of all, we need to raise correct question, and then the questions usually pretty big, so we need to chop down, like decompose as small as possible. Yeah, and then you can create a very simple function that only resolve very small tasks. This is one layer, and then you can also create the other layer. They assemble, disassemble of the first layer, and then they make the other complexity and the other complexity. So this is sort of the mental structure of the architecture of the solution. I mean the computational solution. So this is more about like differentiate issue, problem, tasks, right? And then developing special data structure, which is graph or whatever. List is also graph data structure. The last workshop we learned integer, right? And string, float number. This is also data structure, but this is a very primitive data structure. We're dealing with the spatial information, correct? So we need to tweak or create some, you know, smart data structure that take advantage of, you know, our primitive data structure. That the Python or other software language provided with us. The deep learning algorithm is more about like creating some flow, right? Action flow, data flow, controller flow. It has something to do with the architecture, by the way. So here, the other quick slide here. Come on. Actually, I opened it here. Yeah. So if you guys are interested, just see some video here. But this is the sort of a last, let's say, I have 3 or 4 more images here, which is last material in this hour, I guess. So this is the sort of the diagram of how the software engineer develop CAD system. When I say CAD, it's not AutoCAD. It's computer-aided design system. We can build like a whatever design process or geometry manipulation and visualization things. So this is the surface. This is the UI level. So if you click the some button in Rhino or SketchUp, you basically interact this layer. Okay, and then this layer, you can go, you can go deeper here, and then in this layer, such as like scripting stuff, because all the program has their own API. So actually, the UI is a way of the assemble or disassemble, or way of the having the sequence of the API. So in this level, because the developer opened the API, we can access this API to take advantage. Just like Grasshopper. Grasshopper, I guess, is in between here. If you are familiar with the Max script or Max script, or Ruby script for SketchUp, or Python script, we are interacting with this layer here. And then if you looking at the API, such as Rhino 3D, or Geometry VLab, or Curve, Polyline, there's a lot of classes, right? So basically, they encapsulate a lot of like complex mathematical equation of the geometry behind the scene. This is this level. So maybe I highly recommend you, if you really want to become computation design, you must familiar with the analytical geometry and computation geometry, which is, I think, a bottom line. Yeah. So in this context, you need to get familiar with the transformation, matrix calculation, like a coordinate system, the real 1, 2, 3 space, and vector geometry, things like that. And the other layer, all the way down, is like a very framework. So for example, like OpenGL, WebGL. Rhino is basically built, I guess, OpenGL, either OpenGL or DirectX, because the Windows platform. So this is the maybe too low for you guys, but I think I just share the diagram here. So this is the how we build, how we, like, let's say, decompose the code structure. So this is application. I mean, the facade of the program, such as Maya or Rhino, things like that. And then we have 3, I mean, based on the developer, based on the software engineer, they all have their own count, but I usually do this like this. So I'm gonna talk about like MVC pattern, which is one of the very old and well-known structure. View, model, controller. So view is more about like building UI. And then also we have controller. I think this too is necessary, because the UI is basically receive event from you. Yeah. And then controller is smartly control all the interaction and then cook the geometry inside of the implementation side. So this is how the data flows. Yeah. So for example, if you enact, right, because you want to control something. So as I said, I'm not going to directly control the point or line or node or network, for example. This data goes to active command flow first. And the active command is smartly sorting and then figure it out what's going on. And then it passes to the common process. And common process might have a lot of, it's like a command center, right? And then they directly manipulate the geometry. Yeah, this is some of a hierarchy. Yeah, to think about like a structure of the company or structure of your research lab. Yeah, So it's always like a hierarchy, segmental structure things. Yeah, I think we visit 3 different materials. Yeah, I don't know whether it helps or not, but I'm trying to explore and address some concept of computation design for you guys who has no computation background or whatever things. So we're gonna have a, let's say, 5 minutes break, and then we will have main dish of this lecture. Great. Any question?
I have a question.
Yes, please.
Yeah. First of all, thanks a lot. This was a great lecture. Like, I really like the workflow. Sometimes when I do like a computational design task, the problem I face is some debugging. So can you share some tips? Like, I look at Stack Overflow for those queries, but I just wanted to know some tips from you.
Okay, so yeah, I mean, when you say debugging, which is question like, how can I design well to me? So, I mean, there's a lot of answer, but particularly when I hold your question, there's 2 ways of debugging, I guess. The first one is you know what you want to build, for example, right? But you have no idea how you build. In this case, you can go to Stack Overflow, or whatever website, or some, for example, if you are working in Rhino environment, you know, Manual has a lot of nice documentation in their website, right? So you can go to other community sites, so you can get your own idea to realize or implement your code. I think this is the one thing, because you mentioned the Stack Overflow. The second thing is, which is a more like a generic debugging problem. So even for me, to be honest, I'm work at the same time. You know, I'm actually working, you know, in a company. So I faced a problem, but you know what? What is the problem actually? The problem is I have no idea what is the problem in my code. Yeah, this is actually a problem. So I need to find what's going on behind the scene. I just know the some of the symptom. Yeah, we have a lot of tester or PE, product engineer. They gave me just like a symptom. I need to become like a doctor. Oh, okay. So I feel like when considering your symptom, you need to go to that, I don't know, that department or whatever. So the reason I'm emphasizing the pipeline of our code here is, oops, sorry. Okay. So I think this is a good diagram. So I receive a problem from product engineer, for example, or like my designer. Yeah, I mean, from design team, for example. And then in this case, I install multiple console or debugger in the entry point of this pipeline. Yeah. And then I try to reproduce the problem and then monitor which one breaks. So we basically narrow down. Yeah. But I think the ability to become good programmer is about how you quickly, you know, find the bugs and then raise correct question. Because sometimes you don't need to fix the problem superficially, because problems actually happen inside of the actual, let's say, algorithm. So I think the problem that you face is something revealing. Yeah. So we need to find the correct. I think this is, our conversation has become like computer science developing course, but yeah, I think this is really hard question. But what I'm trying to say is that as much as you can, you need to break down your code. Yeah. And then you can monitor which function or which like a section or part rise problem. So you can basically narrow down and then find the bugs. Yeah.
Yep.
Now
Thanks a lot.
Yeah, interested in, yeah, we can talk later more. Yeah, let's break.
Okay, let's have a break for 10 minutes and we'll see again in 10 minutes then. Cool. Thank you. See you soon.